Hello, this is Algebra, Chapter 6. We'll talk about exponential functions. And then in 6.3, we'll specifically go over the definition of exponential functions, how to determine if something's an exponential function, and then the graphs of exponential functions as well. Remember when we were talking about linear functions, every linear function could be written in the form of y equals mx plus b, but an exponential function is a nonlinear function. So the graph is definitely not aligned since it's a nonlinear function, but it could always be written in the form of y is equal to a times b to the x power. So every exponential function can be written in the form of a times b to the x power. X is your exponent, and then b would be the base. You can't have a be equal to 0, then it would not be an exponential function. B cannot be equal to 1 either, because if b were equal to 1 to any power is 1, and then it would just be a linear function. But a specific example of an exponential function, something like y equals 3 times 2 to the x power, that's an exponential function. Okay, you would have your variable x as your exponent. That's still your input, and then y is your output. Another example of an exponential function is y equals just 2 to the x power. Okay, going back to the first example, in the first example, since this is in the form of y equals a times b to the x power, a is 3, b is 2, and then x is just x. In the second example, a is actually 1, and then b is 2, because y equals 2 times 2 to the x power is the same as y equals 1 times 2 to the x power. But those are each examples of exponential functions. To determine if a function is exponential or linear, remember, if it's linear, there has to be a constant rate of change for both x and y. So for example, 1, if you take a look at x, there's a constant rate of change of 1. You're adding 1 to each input. So far it's linear, but you're actually not adding or subtracting the same thing from y, because here it's minus 4, here it's minus 2, here it's minus 1. So it's definitely not linear, but to determine if something's an exponential function, there has to be a constant rate of change for x, which there is. You're adding 1 every time. And there's a constant multiplier for y. What you're actually multiplying y by each time is 1/2 or 0.5. Multiply by 0.5 here, multiply by 0.5 here. You could also say dividing by 2. That's the constant ratio is what it's referred to. But the ratio for y, 8 times 1/2 or 0.5 is 4. 4 times 1/2 or 0.5 is 2. And then 2 times 1/2 or 0.5 is 1. So this is actually an exponential function. Again, there's a constant rate of change for x, but then there's a constant ratio, which is just some multiplier. Even if you're dividing, that's a constant multiplier. Say you're dividing by 2, that's the same as multiplying by 1/2. If you're dividing by 3, that's the same as multiplying by 1/3, and so on. So that's how you determine if something is an exponential function. Again, a constant rate of change for x, and then a constant ratio or multiplier for y. Maybe take a look at the next couple of examples and see if you could figure out if it's a linear or exponential function. So for example, 2, here's what you should have figured out. There's a constant rate of change for x for sure, plus 1 each time. So it could either be linear or exponential. But then for y, if you take a look at the pattern for y, 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. So there's both a constant rate of change for x, your independent variable, and for y, it's a linear function. And then if you graphed each of those points, the graph would be a line. And then on number 3, okay, there's a constant rate of change for x. You're adding 1 each time. Negative 1 plus 1 is 0. 0 plus 1 is 1. And then 1 plus 1 is 2. Then for y, if you take a look at the pattern, it's a little bit more difficult to see. Well, maybe not that much more difficult. Okay, here you're actually adding a negative or subtracting, so minus 3 minus 3, minus 3. Therefore, it is a linear function. All right, and then on number 5, it says evaluate the function for the given value of x. Here, you actually might need a calculator. So on number 5, y equals 3 to the x power, so 3 to the 5th power. What that's the same as, if you're using a calculator, it would be the same as, this is your base, this is your exponent. Your exponent tells you how many times to multiply the base by itself. So it would be the same as 3 times 3 times 3 times 3 times 3. Or on your calculator, you have this button in all likelihood. So that's your exponent button. For entering this on your calculator, you would hit 3, then this button. For some of you on your calculators, this might be a second function button or a shift function button. But then this button right here, 5 is your exponent. So then 3 to the 5th, you should end up with 243. And then on number 6, y equals 1/4 to the x power. So y equals 1/4, and then x is equal to 3 to the 3rd power. If you do that on your calculator, 1/4, you would do 1 divided by 4, basically in parentheses. You use your exponent button again, and then that's to the 3rd power. It's going to give you your answer in terms of a decimal. So it's equal to 0.015625. If you write this out as a fraction, this is the same as 1 to the 3rd power. In the numerator, 1 to the 3rd power is just 1. 4 to the 3rd, 4 times 4 is 16. Times 4 once more is actually 64. So the fractional equivalent would be 1/64. And then on the last example, you're substituting in x is equal to 4. Y equals 3 times 4 to the 4th power. Be careful here. So by being careful, you want to use your order of operations. Your order of operations, you probably remember as PEMDAS. There's no parentheses here. So exponents come first. You actually don't want to multiply 3 by 4, which is 12, and then raise that to the 4th power. That would be the incorrect order of operations. Multiplication does not come before exponents. So 4 to the 4th first on your calculator. You take 4 to the 4th on your calculator. Again, use your caret button. This button right here, the up arrow button, that's 256. Then you can multiply that by 3. So 3 times 256, and then y is equal to 3 times 256 is 768. If you enter all of this on your calculator, let me show you on my calculator how I can enter that in. 3 times 4 to the 4th power. Here's my calculator. So you can see the screen. I'm going to zoom out a little bit so you can see exactly what I'm entering in. I could do 3 times and then 4 raised to the 4th power. It should give me the same answer. If you remember, that was 768. My calculator does the correct order of operations. So you can enter in the entire problem on your calculator as I had it written down.